Now let us consider the following problem. In figure below, what magnitude of constant force applied horizontally at the axle of the wheel is necessary to raise the wheel over a step obstacle of given height? The wheel's radius and its mass are given. To solve the problem, let's consider first the wheel in the case when force F is absent. In this case, there are two forces on the wheel. One force is gravitational force, and another force is a normal force at this point. When the horizontal force F appears, and let's consider it is small, then this force tries to rotate the wheel around point A, and normal force decreases a little. Let's show this again. When force F increases, normal force will decrease, and finally, at some magnitude of force F, it disappears. At this point, of course, there is a force of reaction of the obstacle, which points in some direction, which we will not specify, because actually you will see that we don't need this force for consideration. Next, we conclude that at this state, when force F increases very little, the wheel will rotate around point A as required in the problem. So to find force F, we should consider state of equilibrium at this position, at the moment when the normal force disappeared. In this case, we can use the equation for torque around point A, and according to the theory, the net torque is equal 0. Because force of reaction passes through point A, it generates no torque around this force, and the net torque is the sum of two torques, torque due to gravity and torque due to force F. Now we will calculate torques tau g and tau f. To do this, we need to take into account geometry of the system. Let's note that distance OA is equal to a radius of the wheel. Then we will consider vertical line and horizontal line, which intersect here at point B. And now we see that, for example, for force F, the lever arm with respect to point A is equal OB, and for this reason, the torque of the force F can be written as follows. We take here sign minus because this force rotates the wheel clockwise direction. Then we consider the lever arm for force Fg, which is AB, and then equation for torque due to gravity is as follows. We have here magnitude of force Fg and lever arm AB. We take here sign plus because force Fg rotates the wheel in counterclockwise direction. AB we can find from Pythagoras theorem for triangle OAB. So OB is equal R minus H, and AB is square root of R squared minus R minus H squared. After some simple algebra, we can write that AB equal this formula. Now we plug in AB here, OB here, and tau F and tau G we plug in this equation, and we will have equation for equilibrium of the wheel at this position, which involves unknown force F. The last step is to solve this equation. To do this, we just move this term to the right and divide over r minus h, and we will have the following answer. Using the numbers which we know for r, h, and m and g, we can calculate force, and the answer is as follows. The problem is solved completely. If you like this video, you may want to click like button, leave a comment, and subscribe for the channel.